Let's analyze some power electronics question. So these are very interesting questions and frequently asked in different competitions. Especially this question, it is frequently asked in GATE. So given that average power loss is 500 watts, we have to calculate the switching frequency. So switching frequency curve is given, and we have to analyze it to do this type of question. So as you can see here, when turning on, the voltage is decreasing and the current is increasing, but the rate at which both are decreasing and increasing is different, as the time duration for phi to decrease is 40 microsecond and current to increase is 50 microsecond, and T on is given as 40 microsecond. Same goes for T off. In these type of questions, we have to derive the equations. First of all, let's try to find a curve of the equation of voltage and current. So the voltage is decreasing. That means P equal to the slope. So slope will be 0 minus 200 by 40 minus 0 T, and the slope will be 200. Intercept will be 200, and this will be phi 200 1 minus T by 40. Same goes for current. For the current, it will be I equal to maximum current is 100 T by 50. Now the power is simply phi I, but we cannot directly calculate power here. We have to go through by calculating energy. So E on is simply the integration of phi and I to the turning on period, that means 0 to T on dt. So writing the equations here, 200 1 minus T by 40 into 100 T by 50 dt. The duration is 0 to the turning on time is given as 40 microsecond, so it will be 40. By calculating this integration, it is very simple integration. We can get the value of 0.1067 joule. Now for turning off, again the rate is different. So now as the current is decreasing now and voltage is increasing, we can find the same equation. So current will be 100 1 minus T by T is 60, phi is 200 T by voltage is increasing in 75 microsecond, it will be 75. By doing the same integration, we'll get E off as 0.31 joule. So the total energy will get E on plus E off 0.416 joule. Now the power is simply the rate of energy, and 1 by T we can write as frequency, and this is the switching frequency. We can get switching frequency by simply P by E. So P is given as 500 by 0.46. So in this type of question, we cannot directly use the formulas. If the T on for both the voltage and current is same, then we can use the formula like this. But in most of the cases, the curve will be different. So it is very important to derive the equations to solve this type of question. Now let's move on to the next question. So in this question, latching current is given for S here, and we have to derive the minimum switching pulse to turn on the thyristor. So in this type of question, we have to do the transient analysis. So we here IL, the inductor current the current can be calculated as transient analysis. So it will be I infinity plus I0 minus I infinity e to the power t by tau. Tau is the time constant, L by R. So I infinity, that means the inductor will behave as short circuit. Okay, so the I infinity will be simply V by R, which is 50 by 50, 1 ampere. Again, at the initial condition, the inductor will behave as open circuit. That means the initial current I0 is 0. So the current question is 1 minus e to the power tau L by R. So you can write R by L. R is 50 by 0.25 t. So now to calculate the minimum pulse, we have to put the current, the thyristor will turn on when the current reaches the latching current. So we have to put the current value equal to the latching current, which is given as 60 milliampere. So 60 milliampere. So from this we have to calculate T, and it will be, we can calculate easily, and the value will be 0.31 milliseconds. Now for the next question, so PI curve is given for a power diode. Average power loss and RMS current have to be determined for a 100 ampere constant current for 1/3 of a cycle. So now let's try to draw the curve for the current. So given that it will be turned on or carry constant current for 1/3 circle. Okay, I naught. So given that Pf is 0.4, 0.045 IF. So if we plot this curve, we'll get equation like this. Curve like this. So this straight line has a slope of 0.45, 0.045, 0.045. It is nothing but the resistance. This is the resistance, and this is P1. This is P1. So this is P1. This is the resistance. Now to calculate the average power loss, we use piecewise linear model equation for average power. So it is nothing but P on I average plus I RMS square into R. So we have already got P on and I RMS, R. Now we have to calculate the average power and average current and RMS current. So from this curve, the average current IAV is nothing but I naught dt by d. That means I naught into 1 by third. I naught is given as 100 ampere, 1 by 3. Now the RMS current, for RMS current, we have to use a trick. So what will be the RMS current if this is a full wave? It will be simply I naught. Okay. So to calculate I naught, first of all we have to write the RMS current for the full wave. It will be I naught. Then the duration of the current, that is actually the unknown, and the total period. So in this equation, the duration is 1/3 and root over. So the duration is 1/3 and the total period is 1. So this is root over. So the RMS current will simply become I naught by root 3, and I naught is 100 by root 3. By simply putting these RMS and average in this equation, we can get the average power, and the average current is also asked. It will be 57.73. So this is how this type of question is done. We have to identify the model in which the equations are given. Then we have to find the curve and find the parameters, and also it is very important equation to find the IRMS